It is physically possible for you to intentionally control whether your pupils are dilated or constricted. Now, it takes a lot of practice, so you're going to have to, put in the reps before your next party so you can freak people out. But this may seem a little strange at first because obviously the eyes or the ability to constrict and dilate the pupils did not evolve so you could have a cool party trick. No. This evolved so you could really accurately control the amount of light that is let into the eye. So you might be wondering, well, how can you do this? Because if you look closely at this image here, you're going to see sympathetic and parasympathetic, and those are parts of the autonomic nervous system. And that is your automatic nervous system, meaning you are not in conscious control. So how on earth can you intentionally do something that is outside of your physical control? It's a really weird question. And to answer this question, we are going to be using one of Kenhub's brand new physiology study units. This is all about vision. This thing is dense. You are going to want to check this out. But if you have never seen one of our study units, we're going to go ahead and leave a link down in the description below to a separate but equally awesome study unit on reflex arcs so you can see just how amazing these study units are. This is a premium feature, but it's basically a living textbook. That's exactly what this is. All right, so let's go ahead and look at this image here, because what we're talking about is visual adaptation. So to give you, well, it's probably best to just orient ourselves first with this image. So if we're looking at this central image here, you can see the neutral eye, right? So we're looking at an eye that is just kind of hanging out, right? Everything is in balance. So you can see it here. You can see this is the pupil. Now, real quick, flash anatomy here. The pupil is a hole, which surprises a lot of people. You are actually the reason it's dark is because you're looking into the eye. You're seeing the darkness inside of the eye. The retina, which is going to be that inner layer of the eye, is very dark because it has to be, because if it wasn't, then when light rays, right, when photons would go into the eye, it would bounce around and ricochet off the bright color. And you wouldn't be able to determine with any sense of accuracy where something is coming from. And so it needs to be dark and absorb light. So you are looking at a hole. Now, it's not just like a hole, like there's things on top of it, right? Again, there's like a cornea and there's all sorts of things that we're not getting into here, but it is kind of wild to think that that is a hole. Now, surrounding it, this here is what we call the iris. The iris is a really interesting structure because this has something called the stroma, which is going to be like connective tissue. There's going to be melanocytes. There's going to be fibroblasts. There's going to be some really unique things inside of here. But this is also, well, I guess to say part of it is going to be what we see here, right? So what we're looking at, imagine if you took off the colored portion or a little bit of that stroma, the loose connective tissue that is above this, what you would see is going to be muscles. Now, specifically, it's two muscles. So you can see this labeled here, but it says dilator pupillae muscle. And then it says sphincter pupillae muscle. So the dilator pupillae muscle is going to be this outer ring. So if you look at this, to me, it looks like a pineapple. I'm just going to go ahead and say it. This looks like a pineapple wedge. All of these, you can see the orientation. This is muscle tissue, right? So then surrounding it, you can see this circular shape. That is the sphincter pupillae. So the dilator pupillae is this one over here that looks like the pineapple. And then the sphincter pupillae is the one that's in the circular shape that is surrounding the pupil. But all of this is part of the iris. More specifically, it's part of the stroma of the iris. Now, you can probably already guess what these muscles do just based on their name. And oftentimes this is how muscles work. And those are always my favorite muscles. So if we look over here, we can see that it says dilator pupillae contracted. So again, this is our neutral position. So if we look here, you can see that the pupil is obviously larger. And that's because these lines here, if we even go to here, these lines are representing the fiber orientation of the muscle. And so when they contract, what's going to happen is it is going to shorten like this. And so when it does that, that is going to open the pupil, right? It's going to create a larger opening to the inside of the eye. And the reason for this is pretty obvious, right? This is going to be so you can let in more light, right? So the pupils dilate like this. Ideally, remember, we're going to see some exceptions to this, but ideally when you are in a low light situation. So if you have to urinate in the middle of the night, your pupils are going to be dilated. If it's getting to be dusk, by the way, is when dusk starts to hit, your pupils are going to start to get bigger. They may not be full dilated, but they are still going to start to get bigger because there's less light coming from the sun to obviously brighten up your surroundings. And so the dilator pupillae, its purpose is not, I'm about to blow your mind. It's to dilate the pupil, right? It's to dilate the pupil. All right. Now, what's interesting though is this sympathetic portion. Because the sympathetic nervous system, if you know anything about your divisions of the autonomic nervous system, the sympathetic is part of your fight and flight, or fight, flight, and freeze, right? And so when we're talking about dilation of the eye, it's also not always about letting just more light in because it's a low light situation. It also might be because you need to take in more information. I want you to imagine for a moment that I'm about to get attacked by a bear, right? In that moment, whoom, my fight or flight is going to happen, right? Epinephrine and norepinephrine are going to start coursing through my system. And one of the downstream effects is the pupils are going to dilate. And the reason you want to do that is because you want to take in more information about the situation because you're about to get, I'm about to get eaten by a bear. You're fine. You're safe at home. But that is what is happening, right? So that when we say sympathetic, what we mean here is that this is part of that whole system, right? The rest of the things that happen in the sympathetic nervous system, that's going to be like your heart rate is increasing, your breath rate is going to be increasing, you're sweating, all the things that would happen if a bear just walks through the door, right? So that is under sympathetic control, all right? So if we bounce over here, now what you can see over here, it says dilator pupillae is relaxed. Instead, in this, this tannish box, we can see that it says the sphincter pupillae is contracted. So if we look in here, what we can see are these little arrows. These little arrows are trying to show you that as the sphincter pupillae, which again is going to be this one, as the sphincter pupillae contracts, that is going to constrict the pupil. And this is to, again, ideally let less light in. It's too bright. Like right now, I have two lights shining at me. I have a computer screen coming at me. I have light from the camera coming at me, but yet the room is very dark. And so it's interesting. Every time I look around, my pupils are going to have to kind of like balance because it's like over there, it's dark over there, it's not. Over there, it's dark over there, it's not. And that is exactly what's happening. And so the sphincter pupillae is just going to, the circular muscle is going to constrict, and that is just going to decrease the size of the pupil. And that's exactly what these yellow arrows are trying to show you, that everything went down. So a way to say this is the function of the sphincter pupillae is to constrict the pupil. That is the purpose of the sphincter pupillae. And again, you can see down here, it says parasympathetic control, right? So this is part of your rest and digest system. That's the parasympathetic. And so I like to also call this the Netflix and chill part of your nervous system, where it's like, as opposed to getting attacked by a bear, imagine I'm just trying to digest a wonderful burrito that I just ate and I'm sitting on the couch. You don't need to have these extremely large pupils in order to do to kind of manage that situation, even if it is not that bright. It's interesting. Even if there's a little less light, but you're not doing much, your pupils can also still adjust. And this is why, again, it's not purely about light and not having light. But at the same time, it is ideally that, which is why we see this spectrum here. You can see where it says bright light, you can say dim light, and it's just going to be bouncing back and forth. And this is what is going to be happening every single time that you are moving from a different amount of light. And so you can probably also understand immediately, how this makes sense when in the morning, right after a long night of refreshing sleep, you turn on the light and your eyes hurt. And that is because your pupils were dilated and boom, you just got hit with all that light, and it actually just overloads your nervous system at that time, and it's just too much, and you just need time to adapt to it. So then, how can you intentionally control something that's automatic? Well, the trick is that you're not really controlling the muscles directly. You're influencing the system that controls them. So if you can learn to trigger a mild sympathetic response by thinking about something stressful or exciting, or imagining you're like in a dark room, your pupils will dilate. And then if you flip it around and focus on maybe something really deeply calming, you slow your breath or picture a bright sunny day, the parasympathetic will kick in. So your pupils will constrict. It takes practice, but you're essentially learning to hack your own autonomic nervous system. This is all part of your iris, endlessly fascinating, but this is only one small portion of the iris, or rather the visual pathway in vision. If you want to check out this and plenty more, go ahead and visit that link down the description below. Again, that is a link to a separate but equally awesome study unit. But while you're there, you can also investigate all the other features that come with a premium subscription to Kenhub, and you can investigate rods and cones and just the retina and all the different layers of it. There's so much to these study units. I think you would be absolutely blown away. But while you're down there and you're checking out that link, you might as well hit the like button. You might as well leave us a comment and let us know what else you'd like us to discuss in future videos. But thanks for hanging out with me. I appreciate it to no end, and I will see you in the next video.